The topic I'd like to discuss today is using the appropriate tools for your data science needs. This more so is from chapter 1, but I feel like it's an appropriate topic to cover and very important for any beginner level data scientist. Oftentimes, people try and use Excel for big data or Excel for most of their data science needs, and sometimes Excel just simply does not have the capabilities to do what is needed for a specific data science project. Best case example is once when I was working at Ernst & Young not too long ago, probably around 6 or 7 months ago. I was working on a big data project. However, my managers and executive directors involved were not very comfortable with big data technologies such as Python, SQL, Spark, Hadoop, etc. The client that we were servicing had a big data querying system called 1010 that we utilized, but it wasn't very efficient for exploratory data analysis. For one of the regulations that we were analyzing, called Fundamental Review of Trade Book, we needed to be able to not only query the data, but effectively and efficiently analyze the data in order to see if our client was adherent with the regulation. So, in turn, over the course of time, we attempted to create a number of coverage analysis for various credit derivative products and found that it was nearly impossible as we were querying almost 1 million rows of data. Excel would, as you know, and most of the audience may know, if you have too much data in Excel, it oftentimes crashes and corrupts the file and you're unable to open the file and you lose all of your work. Down the line, we eventually convinced our managers and our executive directors that the best way to do this would be to download our queries into Excel, using them as tables and uploading them into SQL Server. From SQL Server, we could develop our data model, our nice and neat coverage report that we could then write to Excel, and I used the Pythonic system to develop a reporting dashboard. Here we were able to determine whether the data we were modeling was adherent to the Fundamental Review of Trade Book. Overall, we were looking to see the number of trade transactions from this system were adherent to 3 rules, which were: do they have the correct number of observations throughout the year? Are there a continuous amount of observations? And do they have observations for all 12 months? The continuous observation rule got a little bit tricky as it needed to be adherent to 30 days. So in a way, the 12 months rule tested the continuous transaction rule, but it was an extra check, best practice for us. What resulted was we were able to actually complete the project, and originally we had promised 3 deliverables, and in turn we were able to achieve 16 deliverables. And not only that, we were able to establish our presence with the client as the #1 consulting company. The lesson to be learned here in this use case is that the appropriate tools matter. If you go into a project using incorrect tools, you'll often find that you develop cumbersome solutions that may be hard to maintain, or you may not be able to solve the problem at all. A secondary example of this would be I was an instructor for the Python courses at Ernst & Young. They flew me out to California to do a 1-day instruction of the technology team over there in Python. And preceding the class, one of the actuarial pricing teams came up to me and stated that had they known about Python and the easy-to-use syntax and the exploratory data power that existed within the many libraries that, for instance, are held within Spider, the IDE used by Continuum in the Anaconda package, similar to RStudio, they would have been able to develop their pricing program much simpler and in probably a couple hundred lines of code, they said. Whereas the current software that they were using was too cumbersome to manage, and in the long run wouldn't have been able to be maintained. So they took this tool that I taught them went back to the drawing board and were able to develop a more efficient solution. So to wrap up my presentation, the best thing to do in the overall process is to identify the problem that needs to be solved, the amount of data that needs to be cleansed or engineered, and whether you have the applicable tools to do it, and if you don't, figuring out a way to acquire those tools and use them as efficiently as possible.